In the previous lecture, we saw that the congruence modulo 5 relation satisfies all three of the properties: reflexivity, symmetry, and transitivity. When a relation satisfies all three properties, it's called an equivalence relation. An equivalence relation is a way of combining a group of objects according to something they have in common. For example, consider the set of all people, and let R be defined as follows. Okay, for persons X and Y, X are Y, just in case X was born in the same month as Y was born in. Then R is an equivalence relation. Okay, let X be an arbitrary person. X is an arbitrary person. Then X was born in the same month as X was born in. So R is reflexive. Let X and Y be arbitrary people. And suppose X was born in the same month as Y was born in. Then Y was born in the same month as X was born in. Hence R is symmetric. Okay, let X, Y, and Z be arbitrary people. And suppose X was born in the same month as Y was born in. And that Y was born in the same month as Z was born in. Then X was born in the same month as Z was born in. Hence R is transitive. In this example, we're combining all those people who were born in January into one group, and we're saying that any two people in that group are equivalent. Similarly, we're gathering all those people who were born in February into one group, and we're saying that any two people in that group are equivalent, and so on for all the 12 months. This equivalence relation divides up the set of all people into 12 groups: those who were born in January, those who were born in February, those who were born in March, etc. Note that these 12 groups exhaust all of the people, since each person was born in some month. Furthermore, these 12 groups are disjoint, since no person can be born in two distinct months. In other words, the 12 groups do not share any people, and so are completely separate from each other. The 12 groups form what's called a partition of the set of all people. Okay, they form a partition of the set of all people. More generally, if A is a set and A1, A2 through AN are non-empty subsets of A, such that A equals the union of the AIs, and AI intersection AJ is empty for all I not equal to J. In other words, the AIs are disjoint. Then we say that the set of all AI is a partition of A. Okay, the collection of sets AI could be infinite. Let's look at another example of an equivalence relation. Consider the set of all people living in the United States. Let S be the relation defined as follows. For X and Y living in the US, XSY, just in case X lives in the same state that Y lives in. Then S is an equivalence relation. It's easy to see that S is reflexive, symmetric, and transitive. The equivalence relation S divides up the set of all people living in the US into 50 groups, those living in California, those living in New York, etc. The 50 groups exhaust all of the people living in the US, since each person in the US lives in some state. Furthermore, the 50 states are disjoint, since no person can live in two distinct states. The 50 groups form a partition of the set of all people living in the US.